Find the equation of the line tangent at the point 2, -3 to the graph of y cubed minus x squared y plus 4x equals 7. Anytime we are trying to find anything dealing with a tangent line, we will need to find the derivative of the equation we're given. And since this derivative is not solved for y and is not easily solvable for y, we will need to use implicit differentiation to find this derivative. The implicit derivative of this equation, we can treat this term y cubed like x. We can treat the y like x and just use the power rule. So we have 3y squared, but since we're taking the derivative of a y variable, we need to tack on immediately y prime. For this second term, x squared times y, this is a product of two different functions, so we will need to use the product rule for this term. So we will subtract the first times the derivative of the second, and we will add to that the second times the derivative of the first. With this third term, for x, we can just take the derivative of that using the power rule to give us plus 4, and on the right side of the equation, the derivative of a constant is 0. Now all we have to do is find the derivatives left over by by the product rule, and then we will be able to solve for y prime after that. So we still have 3y squared y prime minus, we have x squared, the derivative of the y variable. We can use the power rule for that. The derivative of y would just be 1, but since we took the derivative of a y variable, we need to immediately put on that y prime, plus y times the derivative of x squared. We can just use the power rule for that and get 2x plus 4 still equals 0. Now I'm going to distribute the negative to both of these terms and rearrange these terms so that we can have something to work with. So we will still have the 3y squared y prime minus x squared y prime minus 2xy plus 4 equals 0. The next step is to take any term without a y prime to the other side of the equation, which leaves us with 3y squared y prime minus x squared y prime equals 2xy plus 4, minus 4. From the previous slide, we have 3y squared y prime minus x squared y prime equals 2xy minus 4. To continue solving for y prime, we now need to common factor out the y prime. So that leaves us with y prime times the quantity 3y squared minus x squared equals 2xy minus 4. And the last step is to divide both sides by 3y squared minus x squared. So that will leave you with y prime equals 2xy minus 4 all over 3y squared minus x squared. So we have found a derivative. The original exercise is asking us to find the equation of the tangent line at the point 2, -3. In order for us to find the slope of the tangent line, we need to substitute in the 2 in for any x values in our derivative, and the -3 in for any y values in our derivative. So when we do that, we get 2 times 2 times 3 minus 4, all over 3 times -3 squared minus 2 squared. And this 3 in the numerator should also be -3. And that is the slope of our tangent line that we're looking for. When you simplify all of this, you get -16 over 23. So we have a slope, we have a point, and so I intend to use the point slope formula, which is y minus y1 equals m times x minus x1 to find the equation of the tangent line. In the ordered pair, 2, -3, x1 is your 2, y1 is your -3. So when I substitute those numbers into the equation, I'll end up with y plus 3 equals -16 over 23 x minus 2. If you like to change this over into slope-intercept form, you will get the equation y equals -16 over 23x plus 37 over 23. Either of these answers is acceptable.